Hi guys, today is Unit 4, Lesson 7, Multiple Function Types in Context. Ways of representing functions. You can use an equation, a table, a graph, or in context with words. This is a table, this is a graph, this is an equation, and this is with words. Wow! Example number 1. Consider the following two functions. Compare the x values of these two functions. Which x-intercept is larger? So function number 1 says f of x is equal to x plus 6. And we want to know the x-intercept. Function number 2, you could just look at it right here and see that the x-intercept is at 2. But we have to figure out where the x-intercept is for this one. Okay? So how you do that is you can, or the second function's already in graph form, we can see that the x-intercept is at 2. So to find the x-intercept for the equation, you enter the equation into GeoGebra.com and it will make a graph for you. That is the simplest, fastest way to do it. It will show you more complex ways and tell you to do it more complex ways, but this is the logical way to do it, is to just use GeoGebra and type it in. I'm sure I will show you at some point during this lesson. This is the graph that you get, and you can see the x-intercept is -6. So the question is, which of these two functions has a larger x-intercept? Well, obviously it's this one, because positive 2 is bigger than -6. Function 2 is... It says function 2 is the larger, which makes no sense. Oh, that's because it hasn't told us this yet. But no, that was slope. You had to use the absolute value. The x value at the x-intercept of the equation of function 1 is -6. They're saying this is function 1. Oh, that's right. This is function 1, this is function 2. They're just not in the correct order. This one does have the bigger one. Never mind. Example number 2. Compare the x values of the x-intercepts for the following two functions. Which x-intercept is smaller? We have a written equation right here, and we have it graphed. This one has an x-intercept of -6. We need to figure it out for this one. The easiest way to do that is to just go ahead and graph it. But they're saying this is another way to do it. When solving for intercepts algebraically, set the other variable to 0. So if you don't want to use GeoGebra, if you want to torture yourself, if you want to make it harder than it has to be, which I don't know why you would do that, you're going to set the other intercept to 0. So if we want we want the x-intercept, we want y to be 0. Remember, f of x and y are interchangeable. So we're going to make this be 0. 0 is equal to -1/2 x plus 4, because we're solving for y, because we want to find the x-intercept. When y is 0, then we can find the x-intercept. Okay, so we're going to get x all by itself. Let's subtract 4 from both sides. All right, that's going to give us -4 is equal to 1/2 x. Okay. Now we need to divide both sides by 1/2, or you can multiply by the reciprocal. So I'm going to go multiply by 2 because I hate division. Division's harder than multiplication. I am the laziest person ever. And that's going to give us x is equal to -8. So that means this one has an x-intercept of -6. This one has an x-intercept of -8. So which one is smaller? This one, the formula one, is going to be the smaller one. Okay? The x value of the x-intercept for function number 1 is -8. Since the x-intercept of function 2 is -6, it has a smaller value. Oh, they're saying it's +8. How did I do that? Well, sure, whatever. You know, you do you, boo. Determining the rate of change. I disagree with it being +8. When comparing two or more rates of change, which is the slope, rise over run, okay, you should consider their absolute values. If a function with a slope of 2/3 is changing at the same rate as a function with a slope of -2/3, just in a different direction. +2/3 is going to slope up like that, -2/3 is going to slope down like that, but they're the same rate of change, even though these aren't the same because I can't draw. A function with a slope of -4 is changing faster, it's going to be steeper than a function with a slope of 2, which is going to go like rise 2, run 1. I did so well, right? Anyway, rate of change has to do with the steepness of the slope. The steeper the slope, the greater the rate of change. The smallest rate of change would be no change when the slope is 0. Okay. Here's example 3. Compare the following two functions. Which one has the greatest rate of change? So our first function is f of x is equal to x minus 4, and our second function is this graph. Now, remember, in the formula, y equals mx plus b. The slope or the rate of change is the m. So in this formula down here, m is not written. That means that this slope is 1. Okay, there is a 1 in front of that x. We just don't write it every time, right? So the slope on this one is 1. That means it's going to rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay, the slope for this one, the easiest way to figure it out is to just go ahead and look. Okay, so this is a negative, so it's not going to rise, it's going to fall. So if we start here, another place where it crosses nice and neat is right here. So it's going to rise 2, run 1, or fall 2. So the slope for this one is going to be negative 2 over 1, or just negative 2. So which one has the greatest rate of change? Well, we're dealing with absolute values because it doesn't matter if it's a positive or negative. So this one has the greatest rate of change because it's actually 2. Absolute value means not positive or negative, it's always positive. Okay, that's what all of this garbage says. Here's example 4. Neighboring office buildings are both reporting cases of the flu among their workers. The first cases of the flu in each building occurred on the same day. The number of days since the first cases of the flu in building 1 is represented by the following function, where x is the number of days since the first cases of the flu were reported. The number of the cases of flu in building 2 is represented by the graph, where x is the number of days since the first cases of the flu were reported. So this is building number 2, okay, and this is building number 1, because that's where I always get mixed up. The graph passes through the points 0, 3, 1, 12, 2, 48, and 3, 1, 92. Compare the number of cases of the flu in each building on day 0, and which building had more cases of the flu on day 2. So the first thing I would do on this problem is go to GeoGebra and graph this. Let's see what they say to do. For building 1, the number of cases of the flu on day 0 is found by substituting x equals 0 into the function. Okay, so they want us to solve it for y. So you would take your formula, which is right here. We're going to say y is equal to 0. Y and f of x are interchangeable, and it's going to be 14.25 x squared plus 3. And we want to get x all alone. So we're going to subtract 3 from each side. That's going to leave us with negative 3 equals 14.25 x squared. We're going to divide both sides by 14.25, which is going to give us some ridiculous number. And I hate that kind of garbage. 14.25. Let's get my calculator. We have 3 divided by 14.25 is going to give us negative 0.211, we'll say. So a negative 0.211 equals x squared. So now we're going to take the square root of each side. So I need to know what the square root of this number is. And that gives us 0.459. So we'll say 0.46. How's that? 0.46, we'll say, is what y equals. Okay. What did they say for y? Since f of 0 equals 3, I don't know how they got that. I don't know how they got that at all. But they're saying when f equals 0, y is going to be equal to 3. You do you, boo. A flu in the building on day 0. For building 2, the number of cases on flu at day 0 corresponds to the y coordinate 0, 3. Oh, that's why. Okay. But this is for here. They're saying this is at 3. And we know that because that's one of the coordinate points it gives us. Okay. There were 3 cases of the flu in the building 1 on day 1. I don't know why they say that, because according to mine, there was 1 case, maybe. And on day 2, they're saying they had the same. Okay. I'm not sure why. If we graph this, it will probably show that it's the same. But that's my math, so whatever, I don't care. For building 1, the number of cases of the flu on day 2 is found by substituting x equals 2 into the function. So we have our function right here. We're going to have y is equal to 14.25 times our x is going to be 2 squared plus 3, okay? Which means 2 squared is 4, so we're going to have 14.25 times 4 plus 3, and we're totally busting out the calculator for this. We have 0.25, no, I fat fingered it. 14.25 times 4 is 57, plus 3 is going to give us 60, okay? So, hey, we agreed for once with the math book. Since f of 2 is equal to 60, there were 60 cases of the flu in building 1 on day 2. For building 2, we can see that on day 2 there were 48. Okay, there were 48 cases of the flu in building 2. So on day 2, building 1 had more cases because they had 60 cases. Okay. Don't worry too much about the one that I couldn't agree on, this junk, because as long as you understand the steps, you're going to be fine. And most of it is just reading graphs. Okay, that's why I'm just ignoring it. Here's question number 1. This is your turn. Compare the y values of the y-intercepts for the following 2 functions. So we want the y-intercepts. Okay, which y-intercept is smaller? We have this formula and we have this graph. So pause the video, figure it out, come back. I'm going to show you how to create this graph on GeoGebra. You start your calculator, you come up here. Y and f of x are interchangeable, so I'm just going to put y because it's easier to type. Now we have a fraction, so we're going to put 1 over 8. Then we have x squared. Okay, and this is what our graph's going to look like. And it wants to know the y-intercept. Well, look right there. The y-intercept is 0. Okay, we saw for this one that the y-intercept is 0. And here, the y-intercept, you can see right there, is 2. Okay, so which y-intercept is smaller? It's going to be function 1. Okay, function 1 has a smaller y-intercept written in slope-intercept form. The y-intercept of function 1 is -2. The y-intercept for function 2 is +2. So I got that y-intercept is 0. And they're saying it's -2. I have no idea why. We still got the answer right. Moving on. Question 2. 2 towns both record the number of inches of snow they received starting at 8 o'clock a.m. on a particular day. Town A models their snowfall with a function where f of x represents the inches of snow and x represents the time in hours after 8 o'clock a.m. Town B models their snowfall with a graph. So here's the formula, and here's town B. How many inches of snow did both towns have at 8 o'clock a.m.? And which town had more inches of snow at 6 o'clock p.m.? Okay, so this one you're going to have to stop and think because we have hours after 8 a.m. down here. So this is 8 o'clock, this is 9, 10, 11, 12. So don't get tripped up by that. Pause it, figure it out, come back. This is the same formula as before, so we have the same graph as before, which may be why their intercept was different. This might have been a typo in the book, like they wanted us to have like a -2x squared or something. I don't know. Anyway, if we're starting at 8 o'clock right here and it wanted to know, I think it said at 6 o'clock. Let me go check. Okay, the first question is how much snow did each town have at 8 a.m.? So at 8 a.m., this town, which is town A, had 0 inches of snow. Okay. And then it wants to know who had more snow at 6 p.m. So here's 8 a.m., 9, 10, 11, 12, 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 8 p.m. So on this 12 line, we're going to come up here, see how many inches of snow they had. Boop, right there. 18 inches of snow for town B. Okay. So town A started off with 0 inches of snow, and at 6 p.m. they had 18 inches of snow. Town B started off with 3 inches of snow, and at 6 p.m., so we had 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8. They had, is that 9? 9 inches of snow. So how many inches of snow did both towns have at 8 a.m.? Well, one had 0 inches and one had 3. And which town had more inches of snow at 6? Town A had more at 6. Okay, so it says town A had 0 inches of snow at 8. Town B had 3 inches of snow at 8. So we got that right. And then it says town A had 12.5 inches of snow. I got 18, but okay. And town B had 8 inches of snow. So I wonder how they got 12.5. Again, I'm wondering if these are typos in the books. I know that I put them in right here, but whatever, boo. You do you. Okay. Carl's parents use both shampoo and conditioner when giving him a bath. Carl is a dog, just so you know. This sounds creepy. They bought a 12-ounce bottle of shampoo and a 16-ounce bottle of conditioner. For each bath, they use 0.6 ounces of shampoo and 0.8 ounces of conditioner. Carl's parents really need a life. The amount of shampoo remaining after each bath is represented in the table. So this is shampoo. Okay. Poo. We have to finish it because poo is an important word. Poo. Okay. For each, where X is the number of baths Carl has taken and Y is the amount of remaining shampoo in ounces. So this is the number of baths. This is how much is left. The amount of conditioner remaining after each bath is represented in the graph. Will Carl's parents run out of shampoo or conditioner first? Okay, this is your job. Pause it, figure it out, come back. Well, first, let's just look at these two. We can see right here that they're going to run out of conditioner at bath 20. And look at bath 20, they're going to run out of shampoo. We're done. It was that easy. Now watch, they're going to make it more complicated than it has to be. Okay. X is equal to the number of baths he's taken. Y is equal to the number of shampoo in ounces. Even though the shampoo and conditioner bottles are not the same size and the amount used for each per bath is not the same, the shampoo and conditioner bottles will run out at the exact same time. So I guess it was just that easy to just look and go 20, 0, 20, 0. Okay, this is at the end of the lesson, so write these answers down so you can enter them later. Practice question number 1. We have a function number 1 and we have function number 2. Compare the two functions. Which has the greater y-intercept? Okay, pause it, figure it out, come back. Okay, let's get rid of our old graphs so we don't have anything to screw us up. Y and f of x are interchangeable. It's just easier to type y. So we have 2x squared minus 2. And here's our graph. Let's zoom out. And what it wanted to know, I don't remember. It's looking at y-intercept. So our y-intercept is right here. We might have to zoom in. It's at -2. Okay. For this function, the y-intercept was, oh, it's not 6. I am losing my mind. -2. The y-intercept here is +3. So which has the greater y-intercept? It's this one, function number 2. Here's practice question number 2. We have a function that's in formula form and a function that's in graph form. Compare the rate of change for both functions, which is the slope. Which function has the greater rate of change? Pause it, figure it out, come back. Okay, the rate of change for this one is 2/3. And the rate of change for this one, find a point where it crosses nice and neat, find another one, which is right there. We're rising 1 and we're running 1, 2, 3. So this rate of change is 1/3. Which one is greater? Function 1. This is quick check question 1. I will not tell you the answer to this one, but I will give you the steps to find it. Compare the two functions and identify the y values of the y-intercepts. Which function has the smaller value? Okay. Now I'm only seeing one function here. Yep, we only have one function here. So I don't know if I forgot to write down another function or if there's one that's missing. I'm not sure what's going on. Let me go troubleshoot. I did forget to put in a formula. Okay, this is function 1. This is function 2. Okay, so it wants us to look at the y-intercepts. So the first thing you're going to do is you're going to graph this function on GeoGebra. Then you're going to find the y-intercept. This is the y-axis. So the y-intercept is where it crosses there. Then you're going to find the y-axis on this one and find where it intercepts. And it looks like it intercepts right there. Okay. So that's your answer for function 2. So then what you have to figure out is which one of these answers is the correct one. Okay. Remember that these coordinate points are written in the formula order of x, y. So if you're looking for the y-intercepts, logically, that's going to be a 0 for the x and then a number for the y. Okay, so that's the order they should be written in. So this one right here is already not an option. Okay, so good luck on that one. Interpret graphs in context. The domain represents all possible inputs or x values of a function. The domain represents the independent variable or the action that occurs first. And the domain identifies the type of values based on the scenario. Now there is a question about this towards the end. What you need to remember about the domain is the x value and it does not change no matter what happens. So it's usually things like time. Okay, like no matter what you do, you're not going to stop time, you're not going to speed it up, you're not going to slow it down. Time's just going to do its thing. No matter if you're bouncing a ball or exercising or driving a car, time is just time. Domain does not change. Domain is just going to do its thing. Okay. Range represents all the possible outputs or y values of a function. The range represents the dependent variable or the result. The range does change. Like the height of a ball when you bounce it, that would be the range. Or how much money is in your bank account, that changes because of interest or if you withdraw money or deposit money. The range must identify the type of values based on the scenario, just like the domain. You have to know what the domain represents and what the range represents, okay? The y-intercept intersects the y-axis and often represents the initial value or the starting amount, okay? If you don't know this stuff intuitively, put it in your notes. Here is a check-in. What key characteristics can be used to compare different functions? The domain, the range, the average rate of change or slope, okay? Intervals of increase or decrease, maximum or minimum values, x-intercepts and y-intercepts. Here's another check-in. What does the y-intercept represent in context? The y-intercept represents the value when x equals 0. If x has units of time, then the y-intercept represents a starting value. Here is example number 1. Sam and his friends visit an amusement park for a fun day on roller coasters. They realize that the heights of different roller coasters over time can be represented by different types of functions. They're losers. That's not what you do in an amusement park. The friends record the height in feet of 3 roller coasters for the first 2.5 seconds of each ride. They create a single graph to study their findings. In the graph, x represents the time in seconds, so this is time, okay? And y represents the height in feet. This is height. H-E-I, such a weird word. G-H-T. Compare the average rate of change, so that's the slope, and the range of each of the 3 graphed functions over the first 2.5 seconds. So we have domain and range. Range is the y-axis, okay? And let's walk through this. The 3 functions have different y-intercepts. So you can see here, one intercepts here at 9, one intercepts at 3, and one intercepts at 1. that represent the starting height of the roller coaster. The function graphed with a solid line, this orange one, is linear. It's just straight. Okay. The slope of the line represents the constant rate of change of the function, which is the height in feet per second. Since the height increases by 3 feet for every 1 second, it goes up 3 and over 1. Okay. The rate of change is 3 feet per second. Over the first 2.5 seconds, the function has the range 9, 16.5. Okay, so here's 9, and then it goes to 16.5. That's the range. That's the change in y values, 9 to 16.5. Okay. The function graphed with a dotted line, which is this blue one, is quadratic. You can see it's got a curve to it. Because the function passes through the points 0, 3, and 2.5, 16, the average rate of change of the function over the first 2.5 seconds is y2 minus y1, so 16 minus 3, over x2 minus x1, 2.5 minus 0, which gives us, I can't read it that small, I think it's 5.2. Over the first 2.5 seconds, the function has the range of 3 is where it starts, 16 is where it ends. Okay, that's the range. The function graphed with a dot dash line, this kind of greenish color, is exponential. Because the function passes through the point 0, 1 and the approximate point 2.516, the average rate of change of the function over the first 2.5 seconds is, and they did, you know, y1 minus y2 minus y1 over x2 minus x1, and I can't read that, but it's blah, for the first 2.5 seconds is feet per second. Over the first 2.5 seconds, the function has the range. It starts at 1 and it goes all the way to 16. I will blow this up so you can see what the rate of change is. It's 5.2. I'm sure you cared so much, just as much as I did. Here's example 2. Consider the y-intercepts for the quadratic. So we want the y-intercepts and linear functions in the context of the situation from example 1. So this is the same one we were just looking at, that involves the heights of the roller coaster relative to the time elapsed. The quadratic function shown on the graph from example 1 has a y-intercept of 3. So right there. How does the y-intercept in the linear function relate to the y-intercept in the quadratic function? So we're looking at this one and this one. Okay. The linear function has a greater y-intercept of 9 than the quadratic function, which is at 3. The y-intercept for the diagonal roller coaster represented by the linear function is 9 feet because the line intersects the y-axis at 9. The y-intercept for the roller coaster with the dotted curve represented by the quadratic function is 3 feet, so the linear function has a greater y-intercept than the quadratic function. This is just reading where the y-intercepts are and interpreting it. Question 1, this is all you. 2, cough, cough. Paper airplanes are thrown off the edge of a cliff, which is littering, by the way. The top of the cliff is represented by 0 on the y-axis. So this is the top of the cliff, okay? The flight of airplane A can be modeled by the formula y equals -3/2 x plus 1. The flight of airplane B can be modeled by y equals -x² plus 3. X represents the time in seconds, so this is time, and y represents the height of the airplane in feet above or below the top of the cliff. So this is height, okay? I'm getting to really hate the word height. It looks so wrong. Explain the domain and range in context. So first of all, domain is the x-axis and range is the y-axis. Yay! The domain represents time and the range represents height in feet above or below the cliff top. The domain includes only non-negative values. So when we're dealing with time, we only have positive values. You can't deal with negative time. The range includes both positive and negative values. A positive value means the airplane is above the cliff, so they kind of threw it upwards, like towards the sky. And a negative value means it is below the cliff. The scenario describes the flight of each airplane over a period of time. The time is an independent variable or domain. That's the x value always is. It just does its thing. Time doesn't care what we're doing with airplanes. Time just goes on. The time is an independent variable or domain. It is located along the x-axis. The height above or below the cliff describes the dependent variable and range. The y-axis, the range, changes depending on what your airplane's doing, how high you throw it, what kind of airplane you made, all that jazz. Here's question number 2. The height of a parasail is modeled by a linear function, while the height of a submarine is modeled by a quadratic function. The graph shows their height in hundreds of feet of travel versus time in minutes. So this one is time again. And this one is height again. Use the graph to describe the y-intercept of both modes of transportation. Pause it and figure it out. The height of the parasail is represented by the linear function, this orange line. The y-intercept of the linear function is 0 feet, which means the parasail started in the water before taking off. The submarine is represented by the quadratic function, this blue curve. The y-intercept of the quadratic function is 0 feet. This means the submarine started at the surface of the ocean and then descended underwater. Here is practice question number 2. Salim purchases a new car for $21,000 and it depreciates in value each year. The function y equals 21,000 times 1 minus 0.15 raised to the power of x represents this situation. He purchases a motorcycle which also depreciates each year. He has as many vehicles as we do. Its depreciation is represented by the function y equals 14,000 times 1 minus 0.09 raised to the power of x. On a graph of these two situations, what axis would represent the loss? This is the one that was talking about domain and range, okay? So we have the y-axis and we have the x-axis, and we're dealing with money, and we're dealing with time. So speed round. Which one of these is going to change? Is going to be the independent factor? Boo, boo, boo. The money, it's going to change over time because both vehicles are depreciating in value. Which one is the dependent factor and does not change and does not care what you do? Time. So on the graph of these two situations, what axis would represent the loss? The y-axis. So you would type 2. Now this might be shuffled in yours, so don't just type 2, actually read it. Here's quick check question number 2. Ben is trying to decide which of the 2 candles to purchase. The packaging for the first candle states that the height in inches of the candle as a function of time in hours is represented by function 1, right here. The packaging for the second candle shows the height in inches of the candle as a function of time in hours is represented by the graph shown in function 2. Which candle will burn for the longest period of time? So the first thing you're going to do is take this and graph it in GeoGebra. Then it wants to know who's going to burn for the longest. So it's going to burn all the way until it hits the x-axis, until it runs out of height. That's when it's going to burn out. Okay. So this one is going to burn out at that number in that unit. Okay. Then you have to look at your second graph, see when it's going to burn out, and then determine which of these statements is correct. Quick check question 3. A hot air balloon's path is modeled using this function. A mine shaft elevator's path is modeled using this equation. In both instances, the domain in time is time in minutes and the range is height. So domain right here is time and range is height, okay, in meters. Using GeoGebra, graph the two situations. Which statement correctly interprets the graphs? Either the balloon's going to reach the ground before the elevator, the starting point of the balloon is higher than the elevator, and then there's these two options. Positive domain values don't make sense for either scenario, and negative range values don't make sense for either scenario. So when you graph both of these, you're going to be able to determine the correct answer. Here's example number 1. Shaquin lives 35 blocks away from a parking lot where a drone is launched. The following graph shows the drone's distance y from the parking lot in city blocks at time t minutes, modeled by the function p of t. It also shows Shaquin's distance from the parking lot in city blocks at time t minutes, modeled by the function s of t equals p of, and this should Oh, P of 5, maybe? Maybe it might be P of t. You never know with me. And interpret the meaning of the solution. Pause it, figure it out, come back. So you can see right here, I'm guessing this was supposed to be t, that they intersect right here at the point 735. The t coordinate of the intersection point is the solution of s of t is equal to p of t. At t equals 7 minutes, both, I don't know where that came from because I have 5 here, but both Shaquin and the drone were 35 blocks from the parking lot. Oh, it's because it's right here. Okay, sorry, I got interrupted. Example number 2, Suzaki and Harrison live on the same straight street, but Suzaki lives a few houses away from Harrison. They both leave their houses at the same time and run in the same direction to the bus stop. The equation representing Suzaki's distance to the bus stop is z of s is equal to 620 minus 4.2s. S is the time in seconds, and z of s is the distance in meters. The equation representing Harrison's distance to the bus stop is h of s equals 600 minus 4s. S is the time in seconds, and h of s is the distance in meters. Will Suzaki ever catch up to Harrison? If so, when will Suzaki catch up to Harrison? Find the solution to z of s is equal to h of s. So go ahead and pause the video and figure it out. Okay, they're really stupid and they want you to do it the hard way and create a table of points for each function, which is a total waste of a step because you can just go to GeoGebra and graph it. And this is what the graph looks like. You plot the points and you get this graph, and you can see they overlap, so you have to like really work at it to zoom in and see where they meet up. But they meet up at this lovely little point right here, which is going to be 100, 200. Because of the graph lies above, this means that Suzaki does catch up to and eventually pass Harrison. I guess they don't need the actual point. They just want to know if she does it. Here is example 2. Step 4. Oh, they want to double check that they did it right. And you can go and look at your table graph and you can see that they match right there. You could also see it on the big graph, so you don't need these tables still. They're being stupid. And then you can check your solution mathematically. Okay, so what you do is you take this, and we're using s is equal to 100 because that's the answer we found. So we have z of 100 is equal to 620 minus 4.2 times 100, which equals 620 minus 420, which is going to give us the answer 200, which makes sense because we had the point 100, 200, right? Let's do it the same for this one. When h of 100 is equal to 600 minus 4 times 100, which is then going to give us 600 minus 400, which guess what? Gives us 200, so it is also correct. Here is example number 3. Giovanni is meeting up with his friend Francesca at the amusement park. Giovanni has a longer drive to the parking lot. Francesca lives closer and likes to drive at a much slower speed. I'm like Francesca. The function j of x is equal to 55 minus 54x can be used to represent Giovanni's distance to the park in miles. The function f of x is equal to 31 minus 30x can be used to represent Francesca's distance to the park in miles. In both functions, x represents time in hours. How long will it take for Giovanni and Francesca to meet up in the parking lot, which is 1 mile from the amusement park? So again, they made tables, which is irrelevant because you can just take this formula and plug them into GeoGebra. You end up with these graphs, and you can see that they're going to meet right there. Time in hours. Okay. Which means that 1 hour. Okay, this is a tenth of an hour. Okay, so they're going to meet at 1 hour. So we're going to take our answer, which is 1 hour, and we're going to plug it in for x, which means we have 55 minus 54 times 1, which is just 55 minus 54, which gives us 1. Okay, and then we have 31 minus 30 times 1, which is just 30. So 31 minus 30 gives us 1. These match. We were right. Check in. It's Sanjaya lives 11, I can't read that small. Sanjaya lives 11 city blocks from the library. Orion lives 2 blocks from the library. Both Sanjaya and Orion leave their homes and begin walking. The function r of t is equal to 3/2 t plus 11 represents Sanjaya's distance from the library in city blocks. The function s of t is equal to negative 3/4 t plus 2 represents Orion's distance from the library in city blocks. In both functions, t is the time in minutes. At what time will Sanjaya and Orion be the same distance from the library? What is the distance? So it wants to know the point of intersection and what that number is. So pause it, figure it out, come back. You would graph both of these functions. This is what the graph looks like. You can see they intersect right here, which is at 4, 5, 4 minutes, 5 blocks. And that means that Sanjaya and Orion will be the same distance from the library after 4 minutes. They will be 5 city blocks away from the library. These are the steps to find the point of intersection of the graphs of any two functions. Step 1, if the equations of the functions are given, create a table of points for each function, then use the points to graph the function on the coordinate plane, or work smarter, not harder, and use GeoGebra.com. Step 2, once you have a graph of the functions, find the point of intersection. The x-coordinate is the solution to the equation in which two functions are set equal to each other. So when you have like f of x is equal to g of x, the solution is the x-coordinate. Check the solution mathematically. I'm so tired of this lesson. We've still got like 20 slides. Example 4. Start by analyzing a graph for a given application. You drop a ball off the roof of a school building from an initial height of 32 feet and through a hoop that is 7 feet off the ground. The graph represents how long it will take for the ball to reach the hoop. How many seconds will it take for the ball to reach the hoop? So we're just looking for the point of intersection here. On this graph, there is an intersection point right there at 1.25, and they're saying 7. The t-coordinate of the intersection point is 1.25. That's the time. It took 1.25 seconds for the ball to reach the hoop. Here's example 5. Daquan is throwing a tennis ball for his dog, Beazle, and that is a bomb name. I love the name Beazle. He throws the ball from a height of 5.5 feet, and Beazle catches the ball in the air at a height of 1.5 feet. My dogs could not catch it at 1.5 feet. Yeah, if you're wondering why, you should go watch my guard dog video. The equation d of t is equal to negative 16t squared plus 23.9t plus 5.5 represents the throw of the ball, where d of t is its height in feet as a function of time, t in seconds. The equation b of t equals 1.5 represents the height at which Beazle will catch the ball. Find out how long it takes for Beazle to catch the ball when it is d of t is equal to b of t. So here they made a table, which is pointless and stupid because you can just graph these two functions. And if you look here, you can see they intercept right here at 1.75 seconds and 1.5 feet, because it told us it was 1.5 feet. Check in. Carlisle is shooting a basketball at a hoop that is 10 feet tall. The height of the ball after x seconds is represented by the equation k of x is equal to negative 4.9x squared plus 10.7x plus 6. The height of the hoop can be represented by the equation w of x is equal to 10. How long will it take the ball to reach the hoop? Keep in mind that the basketball must come down through the hoop, so the ball will reach its maximum height before it reaches the basket. So they're saying the ball is going to go up, down, and then here is the hoop. Okay, so they made a table, which is a waste of time, and then they made a graph, and look, you can see right here that it's going to take them 1.7 seconds for it to go through the hoop. Question number 1, this is your turn. The number of adult tickets sold can be represented by the function a of c is equal to 360 minus c. A of c is the number of tickets sold based on the number of children's tickets c. There are 3 times as many adult tickets sold, which can be represented by b of c is equal to 3c. Use the graph to determine the number of adult tickets that were sold. Pause the video, figure it out, come back. The number of adult tickets sold can be represented by the function a of c is equal to 360 minus c. A of c is the number of tickets sold based on the number of children's tickets c. There are 3 times as many adult tickets sold, which can be represented by b of c is equal to 3c. Use the graph to determine... Oh, I already read all that. It's just the point of intersection, which is right here, 90. Whoop! And it doesn't matter because 90 is your answer anyway. Yeah. I'm so done with this. Can you tell? Question number 2. A model rocket is launched straight up from a platform that is 10 meters high. The function gives a height of the rocket in meters after t seconds. At the same time, a bucket is lowered at a constant rate from a different platform that is 40 meters high. The function gives the height of the bucket after t seconds. Use the graph to determine the time when the rocket and the bucket will be at the same height on the rocket's way down. So the rocket's going up, so it can't be this intersection point. Oh, I'm sorry, pause it, figure it out. Oh, look, it's this intersection point, so your answer's 10. I'm so done with this. Here's practice question 4. Tatiana is waiting for Sana to meet her at the store to shop for their care package. The graph represents the travel time of both students. How long will Tatiana have to wait for Shana to arrive? So you find the point of intersection, which is right here, and you come down to the x-axis, which means that she's going to wait 6 minutes for her. You know, I'm glad this isn't hard, but there's times that I'm just like, what is this math book doing? 2 cars are racing on a track. Car 1 stalled at the beginning of the race and had to catch up to try to win. How many hours did it take for car 1 to catch up to car 2? This is a lame race. Hey, look. It took 2 hours. Quick check question 4. A ball is being shot at a moving hoop. The curved line labeled BS maps the path of the ball, and the line labeled H of S maps the path of the hoop. How long does it take for the ball to go down through the hoop to the nearest second? Well, it's the point of intersection right here. And look, I don't even have to trace it down because it gives me the... I'm sorry. I'll shut up. Quick check question 5. There's a high school track meet, and the runners are competing in an 800 meters run. Sakari fell right at the beginning of the race, so his start time was delayed. During which minute of the race did Sakari catch up with Dylan? They caught up at the intersection point, and you need the x value. And then you can come over here. This is time in seconds, and you need to, and it wants to know what minute? I'm so confused. This says time seconds, so it's like second 2, second 3, second 4. So why do we have minute 660, minute 800, minute 4.8? This makes no sense. Like, I'm so confused. Good luck with that one. Whatever. And I wrote you a haiku about candles because, you know, that was my theme. I'm so done with this lesson. If you need help, leave a comment and maybe I'll give a crap enough to do something about it.